Hello to you, I'm Jessie Johnson. I'm going to talk to you about the Earth's field force. Gravity do not exist, the Earth's field force do. That's the EFF. Number one, gravity don't exist. The EFF, or Earth's field force, do. Gravity do not allow all the things we've been taught because much of what we've been taught isn't true. The EFF allows all that we know is real. Gravity don't. Let's look at three basics of the EFF. In order for a system to fly, levitate, or hover, depends on the system's mass, density, type of structure, energy usage, force usage, ambient pressure in gaseous medium, ambient electro and or magnetic field pressure harmonics in an electro and or magnetic field medium, etc., in respect to the EFF, or Earth's field force, if no other forces counteracts it. Such systems as helicopters, airplanes, jets, rockets, drones, birds, hovercrafts, flying insects, Tesla crafts, flying saucers that is, balloons, etc. The EFF, Earth's field force, is zero at every point in and of the field at any point in that field. Let me show you what I mean by this. As this is illustration A. Now, as you can see, it is zero. You see a line of zeros in the middle, in the middle here. It is zero. The field is zero at every point in the field, even if you go 5,000 miles of the field, as you can see here. This is the ground. This is the upper part of the field up here. And here's 5,000 miles of that field, and it is zero. Zero at every point in the field. Hold on. Now, and the acceleration downward is instant at zero, no matter how far from the surface anything is, whether 1 foot, 1,000 feet, 100 miles, 5,000 miles up. Every zero point in the EFF, Earth's field force, field is a stationary point. If an object in the field is stationary when dropped and starts falling, it starts instantly from zero. An example of what I mean by this. Hold on. I'm going to move the camera. This here is a screwdriver. I'm going to drop it. It's right above the concrete here. I'm going to drop it from a stationary point. It will start. As you can see. A little bit higher. Drop it a little bit higher than I did. Zero. If it's stationary, it's zero. It starts to accelerate from a 0 point. I'm going to drop it a little bit higher now. As you can see. Now, hold on, please. Now, to continue, we'll go to number 2. Now, how far does an object fall downward in feet at the end of 1 second? This shows how strong the field is to keep everything down on the surface, including things that don't have abilities to fly, levitate, hover, or move on its own, such as rocks, dirt, nails, shoes, water, bricks, etc. Let's find out how much downward acceleration force or pull down force the EFF have per second. That's the Earth's field force. Now, whatever this pull down force is, the only amount of force that need to be overcome per second, every second, to stay aloft. Why? Because the field is zero at every point in the field. Then every 0 point is the beginning of a first second, or the first second. Given the flying, levitation, hovering, other methods or systems, structure, type, density, mass, pressure differences, etc., if any. Now, that goes for animate objects or inanimate objects. Now, an example of what's meant by this. Hold on. Now, down here on this foam is a nail. Hooked to the nail is a red piece of thread. Right here is a measuring thing of 20 feet. This is 15. This is 16, 14, 13, all the way to the top, which is approximately, about right there or so. Starting at 1 all the way down to 20 feet down here. Now, I'm going to pull the nail up. I'm going to pull the nail up all the way to the top. If you can see the nail, can you see the nail there? Well, it should be able, there it is. It's moving and bobbing. Hold on. I'm going to pull the nail up to the top. I'm going to pull the nail up to the top and we'll begin. Okay. The nail now is at the tip top at number 1, and I'm going to let it drop while counting seconds to see just approximately how far it has fallen within 1 second. 1, 2. Let's see now. 1, 2. 1, 2, 1, 2. Approximately 11 feet. I'm going to do it one more time. Pull it up. Oh. Okay, we're at the tip top. I'm going to let it go. Start counting the seconds. 1, 2, 1, 2, 1, 2. Approximately 12 feet. That's good enough for our purposes. 12 feet is fine. Okay. The sky, and let's continue. Now, the EFF, the Earth's field force's effect on anything is that thing's weight. As long as the system can overcome its own weight by some mechanism, it will continue going up continuously, depending on surface structure type and so forth indefinitely, if there are no counteracting forces to it. All such types of systems have limits, of course, given their makeup or structure. Now, number 3. We'll go to number 3. Let me finish number 2. Number 2 is such as this. Now, look at this illustration, please. Number 1, right up in here. Number 1. The EFF has approximately 12 feet of pull-down force at the end of the first second. That starts from 0 to the end of the first second. Number 2. Every second is the first second for every flying, levitating, hovering, or self-lifting type system, since it can overcome its own weight. Number 3, such as airplanes, helicopters, birds, Tesla ships, flying saucers, that is, UFOs, balloons, flying insects, jets, rockets, etc. Number 4, non-self-lifting systems, such as bricks, pencils, books, rocks, houses, shoes, etc. have one first second with no power to maintain self-flight or to overcome self-weight. Now, let's continue. Now, everything is at a constant of 0 to approximately 12 feet of pull-down force, roughly 10 to 15 feet of pull-down force within and at the end of 1 second of the EFF, or Earth's field force, for the production of its own weight. Weight is in the first second. That's how everything gets its weight, is within that first second. Outside of that first second does not exist for the weight. Weight is the mass, or the energy concentration content per volume, and density, or the mass concentration content per volume in the EFF. Earth's field forces, that is. Now, an object without self-lift to overcome its own weight will continue accelerating downward toward the surface when dropped or falling, increasing arithmetically, addition-wise per second, or per second squared, if there's no counteracting forces, such as this. Look at this for a second, please. An object will fall from any stationary point in the EFF per second squared, or per second. This is an example right here. If this is the feet per second, and up under it is the amount of seconds, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 amount of seconds. If an object is in the field is falling at 16 feet in that 1 second, at the end of that 1 second, then it falls 32 at the second, 48 at the third second, 64 at the fourth second, 80 feet at the fifth second, 96 feet at the sixth second, such as 6 times 16, 6 times 16, 7 times 16, and so forth and so on, to get the top number of feet in second it has fallen, if there are no counter forces acting on it. Now, I would like to thank everyone for listening and watching, and have a very good day.